All right, welcome, Cloud Luncheon Learners. I am Dwayne Natwick. I am your moderator today. I want to welcome Javier Villegas. He is going to spend the next hour talking about performance features in SQL Server and Azure SQL. If you have any questions during the session, feel free to post them in the chat, and we will get those answered. But without any delay, let me introduce Javier and take it away.
All right. Thank you, Dwayne. It's a pleasure to me to be here today again this year. Last year, I also had the possibility to present for this great community. So definitely thank you for the invitation. Thank you for allowing me to present again about all these topics related to Azure SQL and SQL Server, which I definitely love a lot. So let's start. The presentation today will be about performance features in SQL Server and Azure SQL. Let's try to understand a little bit which are the things that we can do with it and how we can take advantage of all this new functionality, which is common today in Azure SQL and SQL Server. A little bit about myself. My name is Javier Villegas. I am from Buenos Aires, Argentina. I work as IT director in the DBA and BI services at Mediterranean Shipping Company. I've been involved with SQL Server for more than 25 years. I am Microsoft MVP in the data platform category since 2016, and I'm also Microsoft certified trainer. Additionally, I am a member of the board of advisors for the Azure Data Tech community and technical speaker in various events. I'm also one of the organizers of our local community down here in Argentina, SQL Argentina, in where we have our monthly events, meetups, and sessions. So feel free to join us. We speak in Spanish mostly, but you are more than welcome to join us. In the left side of the screen, you will see my contact information. So in case you want to reach me for something related to this presentation, or if you just want to do networking, I'm happy to connect with all of you. All right, a little bit about this Azure SQL, let's say, umbrella, right? This has changed recently, so let's cover it quickly, basically to understand where these performance-related features will stand on, right? This is, let's say, the marketing slide that Microsoft present, which is quite interesting because I truly believe that represent the Azure offering quite well, right? We have SQL Server running on Azure virtual machines, right? This is the same SQL Server that we've been using kind of forever. This is what Microsoft calls infrastructure as a service. We will cover it a little bit in a second. Then there are two other services, which are Azure SQL Managed Instance and Azure SQL Database, right? These are what Microsoft calls platform as a service, in where we don't have to take care of the infrastructure and the platform behind the SQL offering, right? We just connect to SQL and we deploy our databases, and Microsoft take care of most of the things behind this thing, right? And then recently, Microsoft added a fourth offering to the Azure SQL family, which is Azure SQL Edge, right? Azure SQL Edge gives us the possibility of running small set of SQL Server features on an ARM device, right? For example, like one of these. This is a Raspberry Pi, and here we can run actually SQL Server and connect with Management Studio or Azure Data Studio if we have to, right? So this is a very interesting offering because, of course, we won't run our mission-critical decision-making workload in one of these, but for certain edge-related environment, like, for example, capturing information coming from sensors, storing it, and even processing them, right? This is a great, option that we may have. So Azure SQL Edge, quite interesting. So today we won't cover Azure Edge. We will focus on the other three that I mentioned before, right? And in terms of SQL Server, well, we know over the years we've been playing with a bunch of versions, right? 6, 6.5, 7, 2000, and until today that we are on 2019. On every single major version, Microsoft was focusing on a specific pillar. For example, BI, cloud, mission critical and performance. Then in 2017, the possibility of running on a different platform like Linux and containers, right? And right now in 2019, the intelligence over the data, right? So what we will be discussing today in terms of performance features are pointed to what Microsoft called the modern SQL Server versions. Those are 2016, 17, and 19, right? So everything that we will be talking will be starting from 2016 onward, right? So in the Azure SQL world, as I said earlier, we have the three offerings, right? SQL Server virtual machines, which is actually something that is quite interesting because, over the year, Microsoft has come with a bunch of best practices on how to install, set up, and deploy a SQL Server, right? So when we go to the Azure Marketplace to deploy one of these virtual machines, some of these best practices are already coming as part of the offering that Microsoft gave us, right? So this is something that we have out of the box, and we don't have to worry about if we have to do it after the installation, right? You know that as for today, maybe if we go to an on-premise environment, we just do the normal installation, and then we need to run a set of scripts to configure several settings just to, make sure that we are following the best practices. In this case, some of these best practices are already coming with the Azure virtual machines, right? So quite interesting and definitely something to take advantage of. And then, as I said earlier, the possibility of having a SQL Server-like service, right, in where we can connect directly with Visual Studio, Management Studio, and just deploy our databases, our application, managed instance, and Azure SQL database, right? So different than many years ago when I started working with SQL Server. Today, SQL is everywhere, right? We know that we can run SQL Server 2019 in any SQL in any Windows server on-premise in a bare metal environment. We also can run, since 2017, SQL Server on the major Linux distributions like SUSE, Red Hat, or Ubuntu, right? We can also run SQL Server in containers, like, for example, in a Docker environment. And if we need to, provide additional high availability or bigger deployment, right, we can use those containers in a Kubernetes environment. And as we mentioned recently, Azure SQL Virtual Machines, Managed Instance, Azure SQL Database, and SQL Edge. So today, we can run it anywhere, right? So which are the main difference that we can consider when we talk about, the original SQL Server product that we go download and install versus the platform as a service offerings like Managed Instance and Azure SQL Database? There are certain things that are quite interesting, which I believe those are big differentiation of the platform, right? So when we use our SQL offering in Azure, we can take advantage of business continuity, high availability, because when we use any of the offering, right, we know that Microsoft, when we do the provisioning initially, they offer us certain level of service level agreement, right? Because there's going to be high availability, let's say, out of the box. We also can take advantage of automated backup and long-term retention for those backups, right? This is quite interesting because that the whole backup strategy, especially if you are trying to certify in any ISO certification, there are certain rules that we need to follow in terms of how to take the backups, where to locate those backups, and how to retain those backups for a certain amount of time. And we can have all that within the offering. And also, if we want to, we have the possibility of doing geo-replication. You know that Azure has presence all around the globe. There are Azure regions or data centers located in multiple points of the globe, right? So it's quite easy to have a replica in multiple zones. So in case of a major disaster, we can use one or the other. Quite interesting. And something that I really like a lot from, not only from the Azure SQL environment, actually for most of the things in Azure, is the possibility of doing scale, right? So we know that if we deploy something, eventually, if we need to assign more, I call it horsepower, meaning processing, memory, faster disk, bigger disk, etc. If we go to the on-premise world, if we have to do any of this, it's going to take some time to buy the hardware, to schedule to install physically the hardware, the memory, the CPU, the disk on the server, etc. That's going to take some time. In Azure, in a matter of few clicks, we can scale, giving to our Azure SQL more horsepower really easy, right? It's interesting because we can scale up, right? But eventually we can also scale down, right? So if we don't need that additional horsepower, right, we can remove some of the processors, memory, and this that we added temporarily. So this is quite the interesting concept because it's easy to handle, right? Something that I like a lot in Managed Instance and Azure SQL Database is this concept of version, right? So unlike SQL Server, which we have a version defined, the set of features, etc., in Managed Instance and Azure SQL Database, we don't have version, right? So we know that is Azure SQL, period, right? In 5 years, in 10 years, Microsoft is saying that there's not going to be a new version. It's always going to be Azure SQL. That means this is a static product or service that is not going to have any new features or something else. Definitely not. Microsoft is doing all that behind the scenes in background without us having to work on a major upgrade, right? So definitely this concept of versionless is quite interesting. The built-in monitoring, well, all the benefit that we have in Azure, plus all the features that Microsoft has in SQL Server per se, right? Microsoft like to call Azure SQL, I mean, the marketing slogan is just SQL, right? So everything that we know and everything that we've been using for years, right? It's not like we have to take it away and start over. No, everything is in there, right? But with the benefit of running in the Azure platform. And then the point that we are here to discuss today, the built-in intelligence, how we can, have intelligent performance in our Azure SQL environment, right? One of the main problems that we know in terms of performance over the year is that, suddenly we have our procedure, our report, which is critical, that normally runs for certain amount of time, and then one day it just starts taking forever, right? Without anyone modifying the code or anything, right? So this kind of variations in terms of the performance, what we call regressions, right, is definitely something that Microsoft is taking it into consideration with the modern version of SQL Server and Azure SQL. And, with these performance features that we are here to discuss today, right, Microsoft is attacking this problem. So trying to maintain reasonable performance, right, along the time without any regressions. And those are the things that we will be discussing from this point onward, right? In terms of performance, well, historically, we have to take care of three major pillars on any SQL Server environment, which are CPU, memory, and I/O, right, meaning storage. If we have a bottleneck, if we have performance problem in one of these three major pillars, well, we know that we will have problems with our workload, right? So, and this is something that hasn't changed, right? Definitely, we need to pay a lot of attention with our monitoring, right? And also taking advantage of the monitoring embedded in Azure, right, of these three main things. So if we have a problem over there, have an alerting system which may help us to take actions quickly. And then there are certain tasks that, again, over the year, we had to take care of, right? Like maintaining the indexes, maintaining the statistics, backups, etc., right? That hasn't changed either. We still need to pay a lot of attention on statistics, on index fragmentation, and make sure that we are paying attention to that as before. Mm-hmm. So, if we're talking about monitoring and troubleshooting performance in SQL and Azure SQL, and again, starting since 2016, the major SQL Server version, back then, the modern SQL Server version, right? Microsoft is giving this concept of, okay, we have your user database, and we will have certain processes, right, which are constantly monitoring the workload that they run on this user database. And if there are regressions, it will take certain actions to correct those problems and continue the execution, right, the upcoming execution in a better way, or at least the way that it was before, right? So trying to address these regressions by itself without us being involved, as for example, before, that when we had these regressions, we need to start taking some measures, doing troubleshooting, and coming up with creative solutions to try to go back to a reasonable execution, right? So this process of monitoring the workload on a user database and taking the necessary actions are the things that we're going to be focusing from this point on, right? So what Microsoft called intelligent performance. These are the features that we will be working on today, right? In 2016, Microsoft came with the very first feature that was intended to address this regression problem, right? Which is query store, which, by the way, is the basic for all the other features, or most of the other features that we will see after that, and the ones that are about to come soon. We will discuss that also in few slides, right? So this is query store in 2016. We will go through the details in a minute. Then in 2017, Microsoft added an additional layer to query store, which is automatic query tuning, right? Then at the same time in 2017, there was this first attempt to address another problem related to the regression, and the feature name is adaptive query processing. That then in 2019, Microsoft rebranded, also adding different capabilities, right, as intelligent query processing, right? Then, we have these features, column store and in memory, that definitely help us, if we use them to have, good performance for certain scenarios. And then also in 2019, Microsoft started this concept of improving let's say the configuration of the TempDB. We know TempDB is one of these critical databases, system databases that we have on every single SQL environment, right? So they made a change that definitely helped us to run our workload much faster, right? So these are the features that we will be covering right now, right? So again, intelligent database or intelligent performance is kind of a way of trying to accomplish the main objective, which is putting our user databases in kind of autopilot, right? We put it there, we configure all these features, right? We take advantage of these features, and we can accomplish intelligent performance, right? One of the important things for all these features that Microsoft has in mind is that it doesn't require you or the developers to rewrite the code, right? This is quite important and really interesting, because again, it's not something that, hey, we are telling you to rewrite this store procedure this way to take advantage of something. No, all this will be without any code change, right? So we will see it in action, and definitely it's quite interesting. All right, so we will start with query store. Query store definitely, as I said, is the foundation of most of the other performance-related features. And basically what query store is the possibility of enabling this query store. Consider query store, or we can compare it with the this flight boxes, these black boxes of every single flight that captures everything from a particular flight, when it lands, when it's arrived, all the statistics, everything, and save it into somewhere. Well, this is something similar for your user database. So query store will store every single execution of every single query, store procedure, ad hoc, anything in your user database. It will save the plans and the runtime statistics, meaning how many times this particular query was executed, which was the minimum execution time, the maximum, the average, etc. Right? So again, consider that everything that we do is going to be stored within the same user database on a dedicated schema, right? And we will have all the performance information stored over there. Every single plan, right? You know that when SQL Server compiles, it comes up with a plan, it put it in the cache to reuse it in further execution, but now it's also storing that plan within the query store repository. Right? And why is that? Why is just storing this? Well, we will see in a minute what we can do with all that information, which from my point of view is really, really awesome. So how this query store works? Well, we have our store procedure that will be executed for the very first time. So SQL Server will compile it, right? And with the compilation, it will get an execution plan. That plan will be stored in the cache, as I said, and will be also stored in the query store repository. Then the store procedure will be executed, and after the execution, we will have all the runtime statistics, how long it took, how many reads, writes, etc. And also that information will be saved into the query store scheme, right? This is just monitoring, nothing else. Just storing this information, and that's it, right? But it's, as I said, quite important for what is coming next. Enabling a query store in a user database is quite easy. We go to the database property, we will see that there is an option called query store, which by default in SQL Server is disabled when we create a new database. But interesting enough, if we create a brand new database in managed instance or Azure SQL database, it is enabled by default, right? So we have, just enabling, we have this up and running, right? Of course, there are certain things that if our database or if our instance is definitely heavily loaded, well, we may need to do some adjustment. But just, enabling query store, we have it up and running, right? There are certain scenarios that we can use query store. As I said, imagine that in managed instance or Azure SQL database, it is enabled by default, right? So we have this for every single database that we have in there. In SQL Server 2017, Microsoft added something else to query store, which is the possibility not only to store the plan and the runtime statistic, also storing the weights for each query execution, right? So with that, we can also get a better, we have within the query store repository also the weight types for every execution over there. So as for now, we are just capturing this information. So what can we do with all that? Well, first of all, if we go to Management Studio, we have under Query Store a predefined set of reports that will help us to, understand the performance in our database. For example, see all the queries that have regression. See the top resource consuming queries, right? So we can see which are the most expensive ones, right? And then one of the parts that I like a lot. Consider that you find one of the procedures that you have within Query Store, and you see that it came with a new plan, right? Because, it just compiled a new plan, and this new plan is not as efficient as the one that was in use before, right? And you found that, and you see it in your Query Store report. So what can you do to, improve that? Well, Basically, in Query Store, you can quite easily force for a given store procedure within Query Store a previous plan. So if it came with a new plan, which, as I said, was not as efficient as before, you can manually force to use a more efficient plan that was compiled in the past, right? So consider this. You can come back to how was the execution numbers before that, right? In few clicks or just running one store procedure, right? SP Query Store 4 plans, right? Eventually, you can enforce the plan as well, right? So again, if you detect a regression there, you go to Query Store and easily force the plan or enforce it. We're going to see it in action in a minute, right? So here there are some best practices related to Query Store that we can definitely follow, especially if our workload is quite heavy, right? There are certain trace flags that eventually we may need to enable if, as I said, it's a heavily loaded environment, right? So Query Store, quite interesting feature. So then in 2017, Microsoft say, hey, Query Store is good. It's really great. So it's helping us to identify the regressions, and then manually, the DBAs just go there and manually force it. But what if we add an additional process at the top of it that automatically detects the regression? And if there is one regression, automatically we set the plan to the last known good plan, right? That solves the problem that, for example, let's go back to the previous example in 2016. Let's say that the regression happened at 2, 3 a.m. in the morning when we are sleeping, and we come to the office at 8 a.m. and we find the regression and we fix it at that point. Well, from 8 a.m. onwards, it's going to run well. But between 3 a.m. and 8 a.m., we were running our processes with the regression. Well, if we enable automatic query tuning at the top of Query Store, at the moment that it detects a regression, it will automatically set the last known good execution plan. So if the regression happened at 3 a.m., right after, it will set a known good plan, and the performance will go back to normal. Really, really good, right? So this is, again, starting 2017, quite interesting, and we can use it. And we have it available in SQL Server and Azure SQL, right? There is an additional feature that we will cover in a second, automatic index management, only available in Azure SQL database. We will see it in a second. So how does it work? Well, again, it's a process that is continuously running. It learns, meaning storing the information within the Query Store, right? Adapt, meaning that if detect a regression, it will set to the last known good plan, and then the upcoming execution, it will verify that the runtime information is as good as it was before. So verify that the change that was done is in fact better than before, and will keep continuing, because this is not like a one-time only thing. If this happen again in the future, it will automatically keep adapting and adjusting the execution plan, right? So just to make it clear, when we have a plan that a query that is running, that it could change the plan over time, and one of them could not be good, right? So we have the regression. So what this does is automatically assigning the last known good plan, and from that point onward, it just runs good. As I said, in Azure SQL Database, we have an additional flavor to this, which is the possibility of creating and dropping indexes on the fly. So besides checking the regressions on the plan, if Azure SQL Database detect that we may need in our user database a new index to make our workload faster, we have the possibility of enabling the auto creation, and it will create that index on the fly for us. And eventually, if we decide if that index is not in use anymore, it can drop it also automatically, right? Quite interesting feature that for certain options is really, really interesting, right? Definitely need to be tested carefully. Then we have this other feature called adaptive query processing, which is really, really innovative and nice. You know that in the past, when SQL came up with an execution plan, right, that plan was kind of static, right? So we got that plan, and SQL Server was using that plan for, until it came with another one, right? So that plan quite static, and we use it. Well, with this adaptive query processing feature, what Microsoft is trying to get here, and on every single SQL Server version is adding more and more features at the top of it, or more cases, not feature, right? Is that if SQL came with the plan, it executed using that plan, and it detects that that plan may have some problems, right? It will try to come up with a feedback to the engine and say, hey, we should adjust this or that on that particular plan to make it better. So it's not static anymore. It can have some feedback from the engine, from the runtime, and adjust certain things, right? And with that, Microsoft came with this framework called adaptive query processing, right? That for these three specific scenarios, batch mode, query grant feedback, adaptive join, and interleave execution, right? It was adjusting all these values on the fly. In SQL Server 2019, Microsoft added an additional layer, and it rebranded it as intelligent query processing, right? Adding more and more cases to this framework. The best example that I have for this, and we will see it in action in a minute, is the ones related to memory grant feedback. Imagine that you have your SQL Server instance, your user database, and one store procedure. When SQL compiles the store procedure, it says, hey, I will grant you 10 megabytes of memory for that execution. Very good, 10 megabytes. So then the upcoming execution, right, it ended up using only 1 megabyte of those 10s that were initially granted, right? Okay, you can tell me you are wasting 9 megabytes, but with the amount of memory that the server has today, we won't have any problem. But what about if I tell you that this particular store procedure is being executed hundreds of times in a minute, right? We will be wasting a lot of memory, right? And what if we have the other case? SQL Server granted 10 megabytes of memory, but then in the upcoming execution, right, it ended up using 20, right? SQL Server will execute it. It will give us the result, but it will use the 10 dB, right, to spill all the necessary memory that we need from there, right? And most probably what we will run it will take forever, right? So these are the cases in where after executing it, right, the engine will detect that we are either needing more memory or not using all the memory that was granted, and adjusting the memory grant for the upcoming execution, right? This is really, really interesting, and we will see it in a second. Then another one that was introduced in 2019 is this concept of scalar UDF inlining within intelligent query processing. You know that historically, when SQL Server was executing a scalar function, it was not considering like it has a lot of weight within the whole plan. So it was just saying, hey, this has nothing, so let's not consider it for the overall execution. And we know that we can put a lot of interesting or creative logic, let's say, within a scalar user function, right? And that at the end of the day, when we ended up executing, we had this huge performance problems. All right, with intelligent query processing with scalar UDF inlining, what SQL Server is doing is it is compiling the guts of the scalar UDF function first, and then adding it into the main plan. So this way, the plan that came from the execution was much more accurate than what it used to be. And at the end of the day, the execution was much, much better. Right? So quite interesting adaptive query processing and intelligent query processing. So how do we take advantage of all these features? Well, quite easy. We just go to our user database and we change the compatibility level to either 140, 2017, or 250, 2019. And with that, intelligent query processing is enabled, and we can take advantage of all this, right? And again, as I said earlier, without changing our code, right? Then there is an additional feature which I like a lot, which is lightweight query profiling, right? Imagine that you are running a store procedure, a query in your SQL Server, and you would like to know at what point of the execution the store procedure is at, right? So you want to know if at 10%, 50%, or if it is about to finish, right? Well, with this feature, lightweight query profiling, available in SQL Server 2019 by default, enabled by default, we can have for every single execution, right, the estimated query progress. So we can see easily, right, an estimate query progress at which point of the execution is at, right? So we will see it in action, and you will love it immediately. Something that Microsoft did also quite interesting, because since this feature is quite useful, it ported back to 2016, starting Service Pack 1, and 2017. It is not enabled by default. We have to enable the trace flag 7412 if we want to use it, right? But we have the possibility of using it, right? So let's see all this in action. All right, let's start with lightweight query profiling. Here I have my user database, and I have my simple query. What I will do here is that I will enable live query statistic here, right? So we have it here. So what I will do is I will execute my query, and down here, right, you can see that we have the plan just moving, and here at the top we have the estimated query progress up here and down here, right? So we see that we are at this point of the 44% of the execution for this particular query. So what I will do now is I will cancel it, and we run another. So this one again is moving, and see up here is giving us the estimated query progress, right? So we see at which point of the execution we are at. And with that, we can take better decisions, right? If it is about to finish, we may wait a little bit longer. If after several hours it is at the 10% or something like that, we can take another kind of decision, right? So quite interesting. And as you can see, again, we just see it here with for every single query that we run. Now you can come to me and tell me, hey, this is nice, but I don't run my workload through Management Studio. I have my middle tiers, I have my application server, my web server. How do I see this in there? All right, it's quite easy. I will show you here. I will basically generate some random workload on my user database. So this is just running. So if we check, we go to my instance in Management Studio. I go to Activity Monitor, right? And when I go to Activity Monitor, you get certain overview of processing time, IOPS, etc. And then down here you have the possibility of seeing active, expensive queries, right? These are the queries that are running. If we do right click, we see here that we can have the live query plan. So I go here, show me, and with that, I see the query that at this point is running from an external application, right? And I see the estimated query progress for every single query running on our server, right? This is quite lightweight, so it's not hitting your workload too much, right? So definitely take advantage of it, because you can get a quite nice insight for this, right? So this is live query statistic and lightweight query profiling. So let's close this, and also let's close this guy, right? So then I have here my query store lab, right? And for this demo, I won't be using SQL Server 2019. I will be using my managed instance, right? Here, this is a managed instance that I have deployed, platform as a service, and in that I have this database called Query Store Demo, right? So as part of the demo, what I did before was just create the database, right? And remember, in managed instance, Query Store is enabled by default. So I just disabled for a matter of the demo for some time. Then I create a table with 3 columns, and then a store procedure, which is, if we call it with a different parameter, it will be doing certain select on that table. And then, I added certain random rows to my table. So if I do a select from table, we see that we have random information, right? So at this point, I will enable Query Store for my user database. So then next, I will execute my store procedure 20 times, right? So, all right, I just execute it. So I go to the database, I expand Query Store, and then I will go to top resource consuming queries, right? So when I go here, we will see that we have only one query running on my server, and we have it stored here. This is the plan that it came, and if we go and check the grids, we see that it was executed 20 times, right, with a minimum direction of 7 and a maximum of 8, right, plus minus. All right, very good. So then I will create a non-cluster index in one of those columns, and I will execute my store procedure again 25 times. I will go back to my query store report, and now we see that for the same query ID, we have a new plan, the plan ID 2, right? Which is taking advantage of the index that I create. So if you see down here, the shape of the plan is quite different, right? If we go to the grid again, we see that for the query ID 1, now with the plan ID 2, now it was executed 25 times, and minimum duration was much smaller than before, right? If we go back here, I will create another index covering 2 columns, and then I will execute the same procedure 30 times. Go back here, and now it came with a different plan, with the plan ID number 3, which is, the shape, again, is quite different because it's taking advantage of the new index. Going here, right, I see again that for the same query, now it's much, much faster than before, right? And we can have this running all the time for all the database and for all the queries in my user database. Let's say that for some reason I want to use the plan number 2 because I decided to. So I will highlight it, and then here I have the option force plan, right? So I just force the plan. It's just asking me for confirmation, right? So now we see here that there is a tick in there. So from this point onward, it will be using this plan because I force it manually, right? Very good. This was query store. Quite interesting. So now we will see something that, from my point of view, is even more interesting. We will go back to SQL Server at this point, right? And what I will show you here is, we will have one user database with query store enabled, right? And we will, if we see here, I have my performance monitor just giving me the batch request per second for the whole instance. So I will clean there, and we see that we have an average of 70, let's say, batch requests per second. What I will do here is I will introduce a regression, right? There is a regression in the plan, and we see that from this point onward, right, the batch requests per second went back to 10, 15, right? So we have a regression in our workload here. All right, very good. Let me close this. So now it went back to 0. I will do the repro again, and what I will do this time, right, is this one. Is basically go to this guy. Close my script. Here. For my user database, remember, I have query store already enabled. What I will do is I will set automatic tuning force last good plan equal on. When I do this, right, because this one, we will do exactly the same as before. I will start generating random workload. We see here that, again, my batch requests per second go back to 70 in average. Now I will introduce the regression, right? But see what's going to happen right after. The regression is there. Batch requests per second went back to 10 something, but immediately, right away, batch requests per second came back to the number that it was before. And that was because automatic query tuning just set the last known good plan, right? If I go here, I can go and check which was the recommendation and say, hey, you have one query that has a regression, right? So I did manually force the plan to the last known good, right? So again, this could happen at 2, 3, 4 a.m. in the morning, and automatically it will be adjusted on the fly without us having to manually force the plan, right? Really, really interesting. Okay, let's close this. All right, so now let's go to intelligent query processing, and we will see the memory grant feedback, right? What I will show you here is, again, in my user database, I will change the compatibility level to 150, and I will clean the procedure cache. And what I have here is a store procedure that will retrieve certain amount of data. I will put here to show me the actual execution plan. So what I will do now is I will execute that procedure for the very first time with the parameter 8. And you know it will come up with the plan, right? Because it's the first time that we execute this procedure. So when we go and check the plan, we see here that there is a warning sign. So when I go here, we see at the bottom, the query memory granted detected excessive grant. Initial grant was this big number, and we ended up using almost nothing, right? So consider this is the plan that is stored in the cache. So the very next execution, we will execute the same store procedure with a different parameter. In this case, the number 9. At this point, right, it will continue executing, right? It will return. Something is taking several seconds. You see here, it took 15 seconds, and it returned this amount of rows. When we go check the execution plan, now we see warnings everywhere, right? Now we have the grants, and we have that, hey, I needed to spill to the TempDB because I needed more than it was granted initially, and the same thing for the shown, right? Remember, it took 15 seconds, right? And it returned this amount of memory. What I will do next is I will execute again the same store procedure. This time, without any code change, the execution took 1 second, right? It returned, of course, the same amount of rows, right? And if we go and check here, we see that those warning messages disappear, right? And this is because intelligent query process detected the problem with the memory grant and adjusted for the next execution. And the best thing here is that we didn't have to modify the code at all, right? So really, really interesting. All right. Few things to mention. Recently, Microsoft announced SQL Server 2022 that hopefully will show up this year with a set of new features. But for performance, right, they are still investing in intelligent query processing. and there are a few things that we should start paying attention. The most important thing is that in starting SQL Server 2022, for new databases that we create, Query Store will be enabled by default. Right? Here I leave additional links if you want to learn more about SQL Server 2019. Here is the link. Same for Azure SQL, Azure SQL Fundamentals. I leave the links here. And with that, we just finished the presentation. Not sure if there are questions in the audience.
Thank you, Javier. I didn't see any specific questions throughout, so great job. Great information. Appreciate you sharing the SQL Server and the Azure SQL Platform services here today. So really appreciate you taking the time. You got everybody that's attending. There is Javier's information on the slide there, so feel free to jot that down. If you do have any questions that come up after the training, feel free to reach out or post a comment in the YouTube channel as well, and we'll get back to you. So no worries. And I want to thank you, Javier. I know you had a hard stop and got to run off. So we'll see you again next week. Same time, same place, right?
Yeah, absolutely. Thank you, everybody. Have a good day.
Thanks. Have a great day, everybody.
Bye.
Talk to you soon.